Okay, so we just looked at the steps for hypothesis tests, so all the steps you need to take in order to perform a hypothesis test. Now we're going to look at actual examples. Okay, so number 6 here. Okay, suppose somebody claims that mu equals 75. Okay, so maybe you read a situation where, I don't know, it might represent the average age of residents at a nursing home. Okay, somebody may claim that the average age of the population is 75 years old. Okay, test the claim. If alpha is 0.05, so a 5% chance of a type 1 error. The sample mean is 73.6, sigma is 3.1, and n equals 80. Okay, so if you're reading a question, it may say that a certain group claims that the mean age at a nursing home is 75 years old. They collect a sample of 80 patients. They have a sample mean of 73.6 years. And we know the population standard deviation is 3.1. Test the claim at a 0.05 level of significance. Okay, so that might be what a word problem would say. Okay, now the fact that sigma is given to us, that means we're going to use z. Okay, so when we're looking at a z sub alpha or t sub alpha value, that means we're going to look at z, okay, because sigma is known. Okay, so first thing we do is we're going to state, okay, number 1, state HO and H1, and then identify the claim. Well, again, the equality is the null hypothesis, mu equals 75, and that is the claim. So the alternate would be that mu is not 75. Okay, and what that tells us, the not equals to, that tells us we had a two-tailed test. Okay, so what we have to do is we look up what z sub alpha value will have 0.025, which was alpha over 2. Okay, so we took that 5%, 0.05, divide that by 2, and we get z sub alphas is over 2 is negative 1.96 or positive 1.96. Okay, so again, we're through 2 steps of this now. Actually, 3 steps. We identified the hypotheses and the claim. We determined it's a two-tailed test because of the not equals to sign. And then we find the critical region where we're going to reject HO if HO falls, if the z-score for our test statistic falls in that region. Okay, so that would be step 3. Step 4, calculate the test statistic. Well, if we know sigma, what we're going to do is we're going to go back to our test statistics, and sigma is known, so that means we're using this formula, z equals x bar minus mu over sigma divided by square root of n. Okay, so when we calculate the test statistic, x bar is 73.6. That's coming from what they told us here. Mu is 75. Now where that is coming from, the 75, is coming from what our null hypothesis was. We're saying that mu equals 75, so that's mu, 75. And then sigma over square root of n comes from the problem up here, 3.1 and 80. So do that arithmetic in your calculator, you get z equals negative 4.04. Negative 4.04 is going to be in this region over here, which is in the shaded region. And what that tells us is when we make our decision, we're in the rejection region for HO. So our decision, first thing we do is we reject HO. Okay, so that's step 5. Make our decision about HO. Step 6, well, what does this mean for us? How do we interpret that decision? Well, now we go back to what the claim was. If we reject HO, it turns out in this one that HO was the claim. So if we reject the claim, that means we reject HO. There's enough, I'm sorry, I just said that backwards. If we reject HO, that means that we're rejecting the claim in this case because HO was the claim. Okay, so there's enough evidence to reject the claim that mu equals 75. Okay, and if you need to, you can go to the top of the page there about making the decision. Our claim was HO, and we rejected HO. So we're looking at this right here. Not enough evidence I'm sorry, there is enough evidence to reject the claim HO. Okay, so the claim was HO, we rejected HO, so there's enough evidence to reject the claim. Okay, so we can reject that mu equals 75. Okay, the next example. Okay, so same idea. Somebody's going to claim that mu is greater than 1,030. Okay, and test the claim given alpha is 0.01, so it's a 1% chance of a type 1 error. And then we're given x bar s, which means we're going to use t, and then sample size of 17. Okay, so we'll draw our, or state our null hypotheses and alternative hypotheses. Okay, so mu equals 1030 is a null, and then the alternate mu greater than 1030, that's coming from the claim here. And a greater than is a right-tailed test, shaded to the right. So 0.01 area is to the right. So what we need to do is we have to find the critical t value. Okay, so this is our t sub alpha value here. And the way we found that was that there's 1% or 0.01 in one tail with 16 degrees of freedom. Okay, so if n is 17, n minus 1 will be 16. So we look that up in our table, we get 2.583. Okay, and then we have to calculate the test statistic. Well, the test statistic is t equals x bar minus mu divided by s over square root of n. So plug those numbers in. Make sure you put the square root of 17, that's n. Okay, n is 17, not 16. Okay, so make sure you put square root of 17 there in the denominator. Okay, and you end up with a t value, a test statistic of t equals 2.17. Well, 2.17 is not in the shaded region. Okay, it's to the left of the shaded region. So our decision is if we're not in the shaded region, that means we fail to reject HO. Okay, and if we fail to reject HO, we're saying that we cannot reject that mu equals 1,030. So that means the evidence that was presented to us, we cannot support the claim. Okay, there is not enough evidence to support the claim that mu is greater than 1,030. Okay, so again, the idea there is if we fail to reject HO, we're saying that HO looks like it may be okay. So that means we cannot support the alternate hypotheses or the claim. Okay, number 8, p is less than 0.37. So now we're making a claim about a population proportion p. Okay, so on this one, your null hypotheses and alternative hypotheses, we'll write those. Okay, so p equals 0.37 and p is less than 0.37 are your two hypotheses. And this is a left tail because of the less than. So we shade 5% of the area here to its left. Okay, find the z sub alpha value. Okay, and we get negative 1.645. Okay, and again, I just made a note here that the p, when you test a claim about p, you always use z-scores. Okay, so then we calculate the test statistic. So we collected the sample and ended up with a p hat of 0.32, had a sample size of 320. So we use our formula for the test statistic. Okay, and p hat minus p. So p hat was 0.32. Okay, that came from our sample percentage or proportion. And then 0.37, just like with mu, it's coming from our null hypotheses. And then you got to be careful on this. It's PQ inside the square root, not P hat Q hat. The confidence intervals used a P hat Q hat inside the square root. Here, we have the population proportion of successes and failures, so P and Q, not P hat Q hat. Okay, so just make sure you don't make that mistake. Okay, so then you plug and chug goes into that formula, and you get a z-score of negative 1.85. Well, negative 1.85 is to the left of negative 1.645 in the shaded region. So we're in that shaded region, so we reject HO. Okay, and what does that mean? Well, here, if you reject HO, we're saying that HO is no good, so that means it looks like H1 will be okay. So if we reject HO, in this case, there is enough evidence to support the claim that P is greater than, P is less than 0.37. Okay, and as you do these, as far as grading goes, you notice you have basically 5 parts. You have your hypotheses, so there's one part. Your rejection region is the second part, and then you have the test statistic evaluating that, and then your 2 parts of your decision. Okay, so if I graded this out as, say, 20 points, 5 points here, 5 points here, 5 points here, and then 5 points for the decision. Okay, and there's always 2 parts to the decision. The first part is always, what do you do about HO? And then the second part is always, what do you do about the claim? Okay, moving along. Okay, now I give you a few word problems. Okay, so number 9, okay, I'll let you read that. And if you need to pause the video, go ahead, but I'm going to keep on talking for the sake of time. Okay, notice here they told you it was previously determined that the population standard deviation was 0.32, so that means that sigma is 0.32. So what does that tell us? The significance of that is we're going to use Z because we're given sigma. Okay, and I'm just going to show you the answer here because for the sake of time, I think you can work your way through that. Okay, and I'll make a few notes about this as we go on. So you set up your hypotheses. Okay, they're claiming, okay, to test this claim, well, their claim is that the mean reserve capacity is greater than 1.5. So they're trying to say that mu is greater than 1.5. Okay, that's what their claim is. So that's why H1, your alternate hypothesis, is mu is greater than 1.5. Okay, so alpha is 0.10. So that means you have 0.10 shaded to the right here. So that Z sub alpha value is 1.28. Okay, and then you calculate your test statistic based on your data. And then the decision, well, 1.0 is to the left here of 1.28. So that means you fail to reject HO. And if you fail to reject HO, that means we're saying HO may be okay, so we cannot support the claim. Okay, so there's not enough evidence to support the claim that mu is greater than 1.5. Okay, so if you need to rewind the video and go back and look at that, then go ahead. Okay, but again, I'm going to keep on moving on just to make this video not last an hour and a half. Okay, number 10. Okay, another word problem. They took 52 cereal servings, a mean sodium content of 225.9 milligrams, with a standard deviation of 10 milligrams. Now you have to be careful on this one when you read it, and this is a big mistake that people will make. When you read that, remember what we're looking at is when they start talking about a mean, we're looking at mu, but there's 2 possibilities, whether we use a Z or a T. Well, when you read this, when they say the standard deviation is 10 milligrams, they're not saying the population standard deviation, or sigma, is 10 milligrams. They're saying they took this random sample of 52 cereal servings, had a mean of this much, and a standard deviation of this much. So that's referring to the sample. So that means that 10 milligrams is S, not sigma. And that tells us we're going to use T. Can the cereal maker conclude that the mean content is sodium content per serving is less than 230 milligrams at a 1% or 0.01 level of significance? So they're trying to claim that mu is less than 230. So when you set up your hypotheses, mu is less than 230. That's your alternative hypotheses. And then mu equals 230 will be HL, your null. Now we're using T. So this is a T sub alpha value because we're given a sample standard deviation of 10. Okay, so we have 1% to the left, or 1% in one tail. with 51 degrees of freedom. So we subtract 1 there, get 51. Now you'll notice when you look that up, there is no 51. So what you do is you use the closest value. So we're going to use 50. Okay, so if you want to make a note of that, degrees of freedom is 51. So we're going to use the closest. Okay, so we'll use 50. Okay, and that'll give us negative 2.403. Okay, so then you calculate the test statistic and then make your decision. Okay, so I'll uncover that. And if you need to pause or rewind or do whatever you need to do, okay, go ahead and do that. And our decision is that we reject HO because negative 2.96 is out here. So we reject HO. And if we reject HO, we're saying the HO was no good. So H1, we can support the claim. Okay, so there is enough evidence to support the claim that mu is less than 230. Okay, moving along here. Okay, so I'll let you read that one. We're dealing with percentages here. Okay, so we're dealing with percentages. So we're dealing with P. The significance of that is we're always going to use a Z. Okay, so when we make our hypotheses, we have our null hypothesis as P equals 0.80. Alternative is P is greater than 0.80, and that's the claim. So we have 0.1000 and one tail, because that's what alpha is. So that gives us a z-score of 1.28. So we calculate the test statistic. Okay, and what I'll say on this is the sample of 300 graduates had 250 that said they're employed within 6 months. So that your p hat is 250 over 300. Okay, so that's where this is coming from right here. Okay, so p hat is 250 over 300. Now my suggestion is not to round that until the very last step. So when your calculator, do 250 over 300 minus 0.8, press enter, and then divide by parentheses. Okay, put parentheses around the square root here. 0.8 times 0.2 over 300. Okay, and you get a t-score, a test statistic of 1.44, which is to the right of 1.28, so we're in the rejection region, so we reject HO. And then what's that tell us about the claim? Well, we reject HO, so HO was no good, so H1 is good. There's enough evidence to support the claim that P is greater than 0.8. Okay, and then here's the last one. Okay, so I'll let you read that. Okay, and here again, they took a sample of 28 people. Their mean is 6.8 with a standard deviation of 1.2. Okay, so that is X bar and S. Because that sample resulted in 6.8 minutes and a standard deviation of 1.82. So again, that means we're going to use T. Okay, so you set up your hypotheses, HO and H1. Okay, so their claim was that the mean wait time is 6 minutes. So is means equals. So mu equals 6. That's what they're claiming. So the opposite of that is mu does not equal 6. Okay, so again, you look at your T distribution. You have 0.05 in two tails or 0.025 in one tail. Will give you the T sub alpha over 2 values. Okay, so then you find your test statistic. This is T equals here. I mistakenly wrote Z first. So t equals, t equals, t equals. Okay, and again, make sure you put parentheses around the denominator. So I would do 6.8 minus 6, press enter, and then divide by parentheses 1.82 divided by square root of 28. Okay, and make sure you get 2.33 for your test statistic. Okay, and 2.33 we notice is over here, which again is in the rejection region. So our decision is to reject HO. And if we reject HO, notice that was the claim in this case. So there's enough evidence to reject the claim that mu equals 6 minutes. Okay, so those are several examples of performing a hypothesis test. Okay, so hopefully those are enough examples for you to understand what's going on. I suggest you look at the questions online or in the book and do a couple practice ones. And again, what it comes down to is whether or not you use the t distribution or a z distribution. Okay, that's a big part of recognizing what to do, is whether you're using z's or the t distribution.